So for section 4.2, we're going to be talking about relative extrema and graphing polynomials. Another way we can talk about relative extrema, you may have heard the phrase is local max or local mins. So relative extrema encompass both your local max, local min. You may also hear the phrase relative maximum and relative minimum. These are all what we refer to as relative extrema. So a function f is determined to have a relative max. I'm just going to abbreviate maximum as relative max at a particular x value if there is an open interval containing x sub 0, where f of x sub 0 is the largest value for x in that interval. Similarly, f is to have a relative minimum at a particular point where f of x sub 0 is the small value, that is f of x sub 0 is less than f of x for all x in that interval. And if f either has a relative maximum or a relative minimum, then we call that particular point a relative extrema at that particular x value, x sub 0. So let's take a look at some graphs, and they want us to describe the relative maximum or relative minimums or relative extrema at a particular x value. So notice right here at y equals x squared, we would say that we have a relative minimum at x equals 0. Now notice right here, there is no relative extrema. Now right here in the third graph, this cubic, we have a relative max at -1 and a relative minimum at x equals 1. Notice it's not the lowest or the highest point, but in that particular interval we can call that a relative max and a relative min. Notice right here on this x to the fourth graph, we have a relative minimum here and a relative minimum here. We also have a relative max at x equals 1. And notice that cosine of x, you have relative maxes and mins occurring at intervals of pi. So for the relative extrema of the phi function occur at points where the graphs have horizontal tangent lines. Relative extrema, however, can also occur at a point where a function is not differentiable. In general, we define a critical point for a function to be a point in the domain where you have a horizontal tangent or where you're a place where it's not differentiable. To distinguish between these two types of critical points, we call x a stationary point of f if the first derivative is equal to 0. So notice right here, we can say in this particular graph we have critical points here, here. Even though this is a point, it's not differentiable. We can refer to that as a relative extrema as well. So suppose that f is a function defined on an open interval containing a point x sub 0. If f has a relative extrema at x sub 0, then x sub 0 is a critical point of f. That is either the first derivative is equal to 0 or it's not differentiable at x sub 0. So there's two types. So the places where relative extrema can occur is when your first derivative is equal to 0 or it's not differentiable at that particular point. So if you take a look at an example, a relative extrema at these critical points is also where f prime changes signs. So notice that this particular graph, here's my critical point. I have a horizontal tangent line. It is a critical point. It's also what we call a stationary point, because remember, a stationary point is where the first derivative is equal to 0. We refer to this as a relative maximum. Now notice here we have a point of not differentiability. So we still have a critical point at x sub 0, but we do not refer to this as a stationary point, and it's still a relative maximum. So right here we have a critical point at x sub 0. It is considered a stationary point and a relative minimum. So in the fourth graph, notice we've got a sharp point. So this is where the derivative does not exist, but we still refer to that as a critical point. However, it's not a stationary point, and we call it a relative minimum. So right here at x sub 0, this is a unique situation because we have a critical point. It's a stationary point, and it's an inflection point, but it's not a relative extremum because this is where your horizontal tangent line is equal to 0. it is a stationary point, it's an inflection point, but it's not a relative extremum. Because to be a relative extremum, f prime has to change sign. It has to change from a positive to a negative, and as you can see, it does not. It goes from a positive to positive. So here's an example again at x sub 0. It's a critical point, stationary point, inflection point, but again, it's not a relative extrema because, again, the slope of your tangent lines are going from a negative to a negative. So at x sub 0, we have a vertical tangent. It's a critical point, not a stationary point, an inflection point, and not a relative extremum. Again, because the slope of my tangent lines are all positive right here, so therefore I'm not going from a positive to a negative or a negative to a positive. So, which leads us to a theorem which is called the first derivative test. Suppose f is continuous on at a critical point x sub 0. Oops, sorry about that, I just knocked something over. If f prime of x is greater than 0, extending from the left, and then f prime of x is less than 0 on an open interval extending from the right, then f has a relative max at x sub 0. So think about when we were checking for setting the first derivative equal to 0 and doing our number line test. So suppose I have a critical number. If when I do my number line test, I ended up with a positive number on the left, negative number on the right, what that tells me is that my graph was changing from increasing to decreasing. So what happens then, I know that this has to be a relative max at that critical point. If f prime of x is less than 0 on the left and greater than 0 on the right, then I know f has a relative minimum. So if you think about your number line test, here's my critical number. If I have a negative on the left and a positive on the right, remember what that told us is that I was decreasing and then I was changing to increasing. So if I'm going from decreasing to increasing, this has to be a relative min. So think about the first graph looking like this. I'm increasing to decreasing. Here in the second example, I'm decreasing to increasing. So here's my relative minimum right here. Here is my relative maximum up here. If f prime of x has the same sign on the open interval extending from the left as it does on the right, then we do not have a relative extremum. There is no relative extremum. It has to change sign. So if you have your number line, here's my critical number, and this is positive and I'm increasing, positive, I'm increasing, there is no extremum at that particular critical point. So find all the critical points of the function, then determine whether the critical points are relative maximum, minimum, or neither. So basically you're going to do exactly what we did when we were checking for increasing and decreasing, but we're going to then take a number line and interpret the critical point as a relative max or a relative min, or neither. So first of all, I need to find my first derivative. So f prime of x is equal to 3x squared minus 6x. I have to take my derivative and set it equal to 0. So I'm going to factor out a 3x, and that'll leave me with an x minus 2. So my critical numbers are going to be at x equals 0 and 2. So I do my number line test. Here's my 0. Here's my 2. I still want to know where my intervals are positive or negative, so if I plug in a -1, this is a negative times a negative, which gives me a positive. So remember, I do know that I'm going to be increasing for all numbers less than 0. If I plug in a 1, 3 is positive times a negative, which gives me a negative. So I know I'm decreasing. If I plug in a 3, that's positive, positive, so that I know I'm going to be increasing. So notice what's happening at x equals 0. I'm increasing, and then my function is decreasing. What that tells me is I have a relative max at x equals 0. So then notice what happens. I'm decreasing until I get to 2, and then I'm going to change to increasing. So since I'm decreasing, and then I'm changing to increasing, that tells me I have a relative minimum at x equals 2. So now they're asking me for points. We know points have an x value and they have a y value. So it's not enough just to state the x coordinates. So my relative max, again, since it's happening at 0, I'm going to plug 0 in for x. 0 minus 0 plus 12 is going to be at 0, 12. That's my point. Relative minimum. Again, happened at 2. So again, plug in. 2 to the third is 8. 8, and this is going to be 12, so 8 minus 12 is negative 4. Negative 4 plus 12 is 8. So there's my relative max and relative min. So you've got to read the questions carefully whether or not they want the actual x-coordinates or if they want the actual points. So now let's go ahead and try part B. Go ahead and find f prime of x for me. So when we did the derivative on this one, you have to be careful because you have to use your product rule. So there's my f, there's my g. Now, when I simplify this, I just change this into a positive exponent by taking x to the negative 2/5 and moving it down to the bottom. So in order to find your critical points, you do have to condense this down to a single fraction. So my common denominator is going to be 5x to the 2/5. So I have to multiply x to the 3/5 times 5x to the 2/5. So that's going to give me a 5x to the first, or minus 5x. So now I have my common denominator all over 5x to the 2/5. So when I simplify this, I've got 12 minus 8x all over 5, excuse me, I got squished, x to the 2/5. So my critical numbers are going to be from where my numerator and denominator is equal to 0. So my denominator is going to be at x equals 0. That's where the denominator, so again, that's going to be my stationary point. So then when my numerator is also going to be a critical number, which is going to give me at 3/2. So then when I do my number line test, here's 0, here's 3/2. So when I plug in a negative, again, I'm going to plug it into my simplified form. So again, 12 minus a negative is a positive. And then this is going to be, again, I'm taking the 5th root, but then I'm just going to square it. So this is going to be a positive. So I know I'm increasing. At 1, 12 minus 8 is positive, positive. And then a number greater than 3/2 is going to give me 2. That's going to be 12 minus 16. So this is going to be negative. So notice at 0, I'm only going positive to positive. So there is no relative extremum at x equals 0. However, notice from when I approach 3/2, I'm changing from increasing to a decreasing. So I know I have a relative max at x equals 3/2. And then I would have to find the y coordinate to actually find the point.